Day 639 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3010, divide an array into subarrays with minimum cost minimum cost 1. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out the link in the description so you can get you some. Now let's see what the question says. You are given an array of integers nums of length n. The cost of an array is the value of its first element. For example, the cost of an array of integers 1, 2, and 3 is 1, while the cost of an array of integers 3, 4, and 1 is 3. You need to divide nums into 3 disjoint contiguous subarrays. Return the minimum possible sum of the cost of these subarrays. All right, y'all, so that sounds simple enough, but before we get into these examples, let's make sure we know what a subarray is. It says a subarray is a contiguous non-empty sequence of elements within an array. So all that means is the elements in the array are next to each other. Boom. So a subarray, that might be a subarray. This might be a subarray. This might be a subarray because it's contiguous, meaning the elements are already next to each other. An example what is not contiguous is if we took this one, say we deleted this 2 and kept this 3. That's not contiguous. That's not what we want. The numbers need to be next to each other for it to be contiguous. So now that we understand that, let's get into example 1. In example 1, we have our input array, our input nums is an array of integers 1, 2, 3, and 12. The output is 6. Let's take a look at these explanations to see how they got this output, right? It says the best possible way to form 3 subarrays is one. First array is an array integers 1. Second array is an array with the integer 2, and then the third array is an array of integers 3 and 12. So once again, remember we need to break this array into 3 disjoint contiguous subarrays, right? So these are the subarrays that we've broken this array into right here, right? 1, 2, and 3. So the total cost of this would be 1, right? Because once again, the cost of the array, the cost of an array is the value of its first element. Its first element. Boom. So this only has one element, so the first element is 1, this first element is 2, this first element is 3. So we're going to do 1 plus 2 plus 3, right? 1 plus 2 plus 3 equals 6. Boom. So that's just one. That's if we broke it up this way. There are still other ways we could break this array up. So another way we could break this array up, it says the other possible ways to form 3 subarrays are 1. The first array being just having the element 1. Second array has the elements 2 and 3. Then the last array has only the element 12. This will have a total cost of 1 plus 2 plus 12 equals 15. So this 1 plus this 2 plus this 12 is going to give us 15, right? We're doing this 2 because it's the first element in the array. Boom. Another way we could break them up is the first array has integers 1, 2, second array has integer 3, and the third array has an integer 12. That has the total cost of 1 plus 3 plus 12 equals 16, right? So this 1 plus this 3 plus this 12 is going to be 16. But we want to return the minimum possible sum. So out of these 3 sums, 6, 15, and 16, 6 is the minimum, right? It's the smallest sum, so that's why the output is 6. Now, just in case that didn't make sense, let's take a look at example 2. In example 2, our input nums equals an array of integers 5, 4, and 3. This time the output is 12. Explanation says the best possible way to form 3 subarrays is 5, 4, and 3 at a total cost of 5 plus 4 plus 3, which equals 12. It can be shown that 12 is the minimum cost achievable. So in this case, we only have 3 elements to start with in nums, and we need to create 3 arrays right here, like you tell us. So each element is going to be its own array. Then when we add those 3 elements together, we get 12. That's why the output is 12. Now let's take a look at example 3. So in example 3, our input nums equals an array of integers 10, 3, 1, and 1. This time the output is 12. It says the best possible way to form 3 subarrays is 10, 3, 1, and 1 at a cost of 10 plus 1 plus 1, which equals 12. It can be shown that 12 is the minimum cost achievable. Boom. So in this case, we're just going to group these 10 and 3 together, get the minimum cost, which will be 10. Then each one can be its own subarray. So then we add the 10 plus the 1 plus the 1. That's going to give us 12. So boom, y'all. Now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we're going to do is we're going to create a variable for min1 and min2, which will track the smallest and second smallest values found in nums. So we're just going to declare a variable, open up the parentheses, say min1 comma min2, and we're going to set that equal to, just to start as a default value, we're going to set that equal to, open up the parentheses, and we're going to say int.max comma int.max. Boom. Then we need to iterate starting from index 1, skipping nums of 0 because nums of 0 is always included in the final cost. So we're going to come right here, say for I n 1 dot less than nums dot count. So once again, we're going to skip 0 or index 0, because no matter how we group these, index 0 is always going to be included in our cost count. So we could just skip it because we already know it will be included. Like even if we do 1, 2, the cost is still going to be 1, right? So there's no way to just skip this 1, right? So boom. So if the current value is smaller than the smallest seen so far, we need to check that. We're going to use if. Say if nums square bracket I is less than min1, then we're going to shift the previous smallest value to min2. So we'll come underneath this, say min2, set that equal to min1, and we're going to update min1 with the new smallest value. So we're going to say min1 equals nums square bracket I. Boom. Otherwise, if the current value is smaller than the second smallest value, we could check that by saying else if nums square bracket I is less than min2, then we'll open up the bracket and update min2 with the new second smallest value. So we'll say min2 equals nums square bracket I. Boom. Then we're going to return the sum of the first element, the smallest value, and the second smallest value by coming right here, and we just say return nums square bracket 0 plus min1 plus min2. Boom, y'all. That's all she wrote. Let's go ahead and give it a run. Make sure it runs properly before we submit it. Okay, this should be a min1. So let's go ahead and clean that up and run it again. See if that did the trick. And it did. So let's go ahead and run it. Make sure it's still accepted after we run it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.